guys. Good morning, good afternoon, good evening. Welcome to the Ravit Show. We have a very special guest today. It's none other than Kevin, who he is the co-founder and CEO at Metaplane, a data observability company focused on helping every team find and fix data problems. So we'll be discussing a lot around data problems today, data quality problems with as little as setup as possible. Metaplane is backed up by leading investors, including Y Combinator and the founders of Okta, HubSpot, and Lookout. So you can have your questions around the company. We'll be also looking after the having a quick sneak peek around the Metaplane website too. Also, a little about Kevin. He has over a decade of experience working in data. Most recently, he researched the intersection of machine learning and data science at MIT, where he earned a PhD and collaborated with Fortune 500 companies. His research is being published in top computer science ventures like ACM, CHI, KDD, and SNCMOT, and featured in the New York Times, Wired, and The Economist. Today, we will discuss about his journey, data quality, metadata, or as the data for the data team, silent data bugs, and much more. So feel free to have your questions coming in. Also, we have a giveaway today. I know a few folks are already joining. So for those who are joining us, I just wanted to let you know that we are giving one annual subscription of 365 Data Science today. What you just need to do is type in hashtag 365 Data Science in the chat, and by towards the end of the show, what we'll be doing is doing a raffle, and you have a chance to win one annual subscription. All right, let's call our guest for today, Kevin Wu. Welcome to the Robert Show.
Such a pleasure to be here. Big fan of the show. I'm going to try and match your energy level. I don't know how you have so much energy. I know it's late for you and it's early for me, so maybe we can meet somewhere in the middle.
Definitely, I'm looking forward to the chat, and I'm sure you can get your energy with the bio. I know you've done a lot, so I want you to match that energy. And looking forward to learning more about data problems, data observability, about Metaplane, what's happening there. But to start with, obviously, I would love to for our audience. Can you introduce yourself, Kevin?
I don't know if I can match, the great introduction that you gave. I'm still blushing a little bit, but I am the CEO of Metaplane. We are building the Datadog for data. It is a data observability tool that plugs into your data stack, from Snowflake to transformation tool like dbt to BI tools like Looker and Tableau. And we simply tell you when something goes wrong, and we give you the impact that you need to debug and the root cause that helps you save time. And at Metaplane, basically, I write all of the SQL. So when a data connector goes down, it's my ass that's on the line.
Right. So yeah, exactly. That's the most important thing, right? So we would obviously want to learn more about it, but talking about data observability for our audience, can you tell us more about what is data observability and how is data observability different from software observability? Because we see a lot of overlap there, or people kind of talking around software observability and getting it wrong with the data observability. So would love to know more about it.
It's a very good question. In one sentence, I would say that data observability is the degree of visibility that you have into your data systems.
Right.
And it's analogous to software observability, because software is how much visibility you have into your software systems and infrastructure. You might use tools like Datadog or Splunk. And these software observability tools, the one purpose is to collect as much metadata as possible. Metrics, traces, and logs are the three big categories of this types of metadata, so that you can know either right now or at any point in time what was going on in your software system. So that when something does go down, you as a software team are the first to know, and that you can kind of go back in time to figure out what exactly happened. This is the kind of visibility that we and all data observability vendors want to bring to data teams, because right now in 2022, frequently data teams don't have much visibility into what's going on into their data stack. Like, is my data fresh? Are these dashboards up to date? Are all of the records, in the amounts that we expect? It's tough to know the answer to that question. And this is, of course, not the fault of the data team. I think the technology just is not mature yet until now.
Exactly. I think you're right there where you're talking about the technology needs to get a bit matured, and I'm sure Metaplane is working towards it to make sure that the community learns more about data observability and also about software observability. So that makes a lot of sense. We have a few folks joining us. Let's quickly greet them. Oliver is here. Hey Oliver, nice to see you. Mohammed is here. Manisha is here. Nice explanation, she says. Thanks, Manisha.
Thanks,
Definitely
Misha.
learned a lot from Kevin today. Robert is here. Hi, Robert. Thanks for joining. Definitely a great topic. I want to learn a lot from Kevin today. So we'll be putting you as much as we can on the spot, Kevin. So be ready for that. But obviously, to more to learn more about data observability, what do you think, according to you, are the pillars of data observability? How is it, keeping? How are you keeping it there, and then wanting to move forward?
In the sciences and in math, there's this idea of the necessary and sufficient explanation, right? Like, what
Right.
do you need, like, at a minimum to explain something, but you don't need anything more.
Hmm.
And in software observability, the necessary and sufficient information are metrics, traces, and logs. Right? If you Google software observability, it's repeated, ad nauseum, but it does make sense because if you have logging information, so the most minute detailed information that you can get about the state of software infrastructure and interactions with the system. You have traces, which are like time correlated logs scoped to specific requests, and
Right.
metrics, for example, the CPU utilization of an EC2 instance. That with these three, that's all you need, that's necessary, and that's sufficient, right? That's enough to describe the state of a piece of infrastructure. And for
Right.
us, we want to ask, like, what is the necessary and sufficient information to describe the state of data?
Exactly.
These, we think of it in terms of like the characteristics and the relationships of data. And within the characteristics, like if you imagine a table within Snowflake, how do you describe that table? You might say, okay, well, here's like a bunch of names, here's a bunch of addresses, uh,
Right.
and this is null, right? Here's some PII. Or if you have like an age of a bunch of people, you might say, okay, this is the distribution of the age. This is internal characteristics. We call those metrics of a table.
Right.
Or you might say, Kevin, this table is, this is the name of the table. Here's the structure, like the columns, the types of columns, the number of rows, and the last time that it was updated. These are like external characteristics. And we call them
Hmm.
external because you can scale up the number of rows or change the structure without necessarily changing the internal characteristics of data, and vice versa, right? You can make a bunch of rows null, but the external characteristics are the same. So these two are like kind of orthogonal ideas that
Hmm.
you can scale them independently, and with those two, you can describe in like infinite detail, as much fidelity as you want, your data. But ideally, you have all the data, but until we can store snapshots of everything over time, we only have the characteristics. And in the other bucket, we have relationships, right?
Hmm.
Data does not, you don't only have one table in yourself. You have many tables, right? Some teams,
Exactly.
tens of thousands. And relationships within data are typically derived through applying operations to previous pieces of data. This is what is commonly called lineage, right? I got
Hmm.
C because I joined A and B, for a simplistic example, although it goes all the way up, forming like a directed graph of lineage. And of course, you also have relationships between data and other systems, or data and consumers or producers of data, we think of that as logs. So kind of zooming all the way back up for a very verbose answer to your question, we have metrics, metadata, lineage, and logs. Those are the 4 pillars of data observability that are necessary and sufficient. If you lose any one, you lose information. If you add one more, it's a little bit redundant.
Very interesting. These I have noted down the pillars. Definitely somewhere, if someone asked me more about the data observability pillars, now I know, Kevin, what are these, and very well explained. Thanks for that. Also, moving a bit more into the data science bit in terms of for our audience, obviously they would love to know from your experience. You've like had a degree from MIT in PhD. You've earned a PhD there, so would love to know more about in terms of how do you see humans benefiting from data science in the coming years, like in next 2 to 3 years. How do you see the transition happening?
It's hard to predict the future. I can say what I hope, and the hope overlaps a little bit with where the research world is going and where we as practitioners see like the data industry going. And it comes down to automation and augmentation, right? Some processes that are this rote or redundant, that we can automate those processes. And this can be something as simple as like data entry, data cleaning, 2 things that we might interact with in the real world, right? Like document classification, or like self-driving cars. Take a really far example. Of course, it's going to take a long time for us to get to full automation there, but I think data science is at the end of the day, it comes down to like automating what a human has done, or even surpassing human performance in certain domains. But at the end of the day, you can't fully pull humans out of the loop, right? The promise of automating the enterprise has been here for decades, and it turns out to be things that we're very, very good at. Relationships are one of those things, right?
Exactly.
And that's where I hope that data science, if we can use that term broadly to describe like artificial intelligence and machine learning, can really help us do our, do very human tasks better. And this is actually how I got into the data world to begin with, was trying to build better tools to help scientists do research better, where a lot of the times you have very brilliant people collecting data. They know the science, they can reason about it. They just don't know how to code. And that's so frustrating to people. And I think applies to most of the world, right? Most of the world doesn't know how to code, and nor should they, right? Their time and energy is better spent in other places.
Fair enough. I think that makes a very interesting point, where I can easily say that humans are not being replaced by any technology any soon. So we don't need to worry about that. But great points there, Kevin. Okay, that also brings me to something more on the lines where, about your field, and I'm sure you would be the right person to, advise those who are new in data observability as a subject. What would be your advice for them? Like, is it something rocket science, or is it not something that it's not that difficult to get into? Would love to hear your thoughts there.
I think the beauty of working in the data world is that the business is ultimately what matters. I'm assuming that many people in your audience are working on data within companies, right? But like data at the end of the day is only used to describe the world, right? Just like concepts in the world, attributes about those concepts. And if you're getting started with data observability, I would start from what does the data mean, and what is it being used for? And then kind of reverse engineer from there and say, okay, if data means, right, if I have Salesforce data, which has these contracts and these customers, and is being used by my sales team to understand which accounts to target, then you go one level deeper and say, okay, how fresh does the data need to be? And how correct does it need to be? Then go one level deeper and say, how do I achieve how do I know that the data is this fresh or correct? And how do I ensure that? So I think reverse engineering from the task or the use
Mm,
case is the right way to get started. Uh, one, because it aligns you with the people who are actually using the data, right? And if data lands in a warehouse and it's not being used, then is it really useful? So
mm,
it aligns you with the stakeholders, and it gives you a very sharp, focused lens through which to view your efforts. Because if you just start, and I've done this, like just looking at your belly button saying, oh, what's all the ways that data can be correct? There's an infinite number of ways that data can be correct because there's an infinite number of ways that it can be incorrect. So I would, start from the end and it'll keep you focused.
right. And that is definitely, uh, that does help a lot. And we also have a comment here coming from Anisha. That she says, great explanation, not everyone needs to learn coding. That's very true. uh, okay, Kevin, also, since we are on this topic about data observability, why start a company in data observability? What got you to a place where you felt this is the place where you want to develop, and you want to have a company around it? What was the reason?
The reason is because I spent 6 years trying to do research and build tools to automate and augment data analysis.
Hmm.
So, for example, like a tool called Dive or a method called VisML, where you plug in a data set and we recommend the most, interesting visualizations or analyses to you. And when trying to deploy this, research across different companies, including like huge Fortune 500 companies, the biggest problem was never actually having a clean data set and having to analyze it. It was
Hmm.
because the data wasn't clean and the data wasn't in one place. That was actually the biggest problem, which is why we started Metaplane, uh, in the hope that we can help companies at least become more aware of the state of their data quality and slowly build up the muscles to improve it over time. And then, maybe someday when the data is all accessible and it's all clean, then, we laid the garden to help 1,000 flowers blossom. We couldn't figure out the automated data analysis, but maybe someone else can.
Right. And that does make a lot of sense. And I'm sure that's actually, solving a lot of problems you already have. I know for a fact your company is already taking off. I won't let out the secrets, but yeah, would love to, obviously see that progress coming in. We have, oh, Mike Nash is here. Hi, Mike. Nice to see you. We also have Scott Taylor in the house. Hi, Scott. Nice to see you
Hey,
around.
Scott.
Um, we have one question in the audience. I'll quickly take that. Let's do this. And it's an interesting one. What's the difference between AI observability and data observability?
Good question. The future moves so fast sometimes where just 1 year, I mean, right now we're talking about how data observability is a new field and it borrows from software observability. But now sometimes I feel like data observability is becoming old and people have moved on to AI and machine learning already. AI observability is similar in spirit in that you want visibility into a system. In this case, the system is a machine learning model.
Hmm.
And not only machine learning model, but all of the uh, relevant adjacent use cases. I mean, not use cases, but entities, right? Whether it's the upstream features which are being used to train the model, like the production features that are being predicted, or even the parameters, like and the architecture of the model, as well as the predictions coming out. So this is all very abstract, but in reality, what it turns out to be is like I have a recommender system that tries to allocate ad spend. I have
Hmm.
a table with a bunch of features going into it, and I want to make sure that the features don't drift too much over time.
Hmm.
These are the performance metrics of my model, if the AUC curve, for example, and this is how it departs between training and test. So all
Hmm.
of this occurs kind of downstream of where data observability ends. So it kind of like data observability in many ways ends with the warehouse, and AI observability frequently starts with the warehouse.
Got it. So it's like the the start and then towards the end, obviously it's taken by the AI observability. Nice explanation
Yeah.
there, and fantastic question by Aditi. Thanks for
Yeah.
that.
Fantastic question.
Joe in the house, he says,
Joe, the legend.
yeah,
Wow. Web3.
he does mention about Web3 observability. So yeah,
Yeah, that is outside of my pay grade, but I
so
do see that being next up for sure. Once we get some NFTs in our data stack, now we're good.
we should actually have a conversation with about Web3 observability with Joe. I'm sure he might have come up with something you never know.
How can I get out on this, Joe? Please don't hold out on me.
Okay. Another quick question from Mike, very interesting one. For a company, what is the best method of choosing the best data observability tool?
I hate saying it depends, but it does
Yeah.
depend. But like, and I would say there's a few different choices you have to make. One is, do you want an open source tool? Do you want to build it in house, or do you want a commercial offering? There's pros and cons of each. It depends on your budget. It depends on whether you have in-house, talent to be able to build a tool. It also depends on what kind of integrations you have. But let's say if you do decide on bringing on like a commercial tool, there's sales-led offerings where you need to like book a demo, but they're often suited for like an enterprise company. There's product-led offerings like Metaplane. They can kind of try it out, see how it fits into your workflow. But regardless of which one you choose, and I'm not going to say that Metaplane is the best for everyone. It's not, right? No tool is the best for everyone. But what you want is to be able to bring on a tool and have it catch an issue for you. And during the evaluation phase, if it doesn't catch an issue, well, for one thing, if you don't have issues during those 30 days or 90 days, maybe you don't need a data observability tool, right? If an issue does occur and the tool doesn't catch it, then you have your answer already. But if an issue does occur and the tool catches it, now you can go a little bit deeper and say, how much time did this save me? And how much trust do I have and my end users have because we now have this tool? At the end of the day, data observability only exists to increase your trust in data and to save you time. And those are the two like dimensions along which you can evaluate these tools. There's a few little hacks that you can do, like artificially causing an issue. But yeah, that's another ballgame.
Okay, that makes a lot of sense. Thanks for that question, Mike. Okay, wanted to just move forward in terms of wanting to know your thoughts on data quality and data observability, because that is also something which is, I would say, which is more on the lines where we observe data and then we understand the quality, or how does the game works there. Would love to know your thoughts, Kevin.
Data quality is a actual problem that people face. Data observability is not a problem, right? It's a technology or it's a solution. I may have mentioned this before, but like no one wakes up in the morning saying, "Oh God, my biggest problem is data observability." If you
Right.
do, send me an email. I'll hook you up. But like data observability is just technology that collects a lot of metadata about your data systems and presents it in a way that can help address data quality, but also other problems like spend monitoring and data discovery and usage
Right.
analytics. Uh, so oftentimes I would, when someone is talking about data observability and hoping to bring on a tool like Metaplane, I would honestly ask them, like, what kinds of data quality problems are you looking to address? Right? Data observability might not be the best solution there. In the same way that if, if you're building a software system and there's a lot of software quality issues, Datadog is not necessarily the right answer. Maybe you need more unit tests, and you can use a tool like Great Expectations to define those unit tests. Maybe you need better regression testing because things are moving too quickly and some customers are complaining. So then you can bring on a regression testing tool. Maybe you don't have good version control and
Right.
your developers are introducing too many bugs and you want a more CI/CD like solution. But if the main data quality issue is that you are not the first to know about issues, but rather your stakeholders internally, like your chief marketing officer is the first to Slack you saying, hey, why does this Looker dashboard look wrong? Or, your end customers, that's something that data observability is good for.
Okay, that's interesting. Also, since you spoke about waking up with a problem and saying that, oh my god, my data observability doesn't work very well. Kate
Yeah.
say woke up thinking about data observability, and she has an interesting she has an interesting question about Metaplane. So, how did you come up with the name Metaplane? Interesting.
The name Metaplane is, in networking, like computer networking, there is a distinction between the control plane, which is used for logic, and the data plane, which is used for the actual, flow of data. Uh, we wanted to introduce the metadata plane. So
Hmm,
one place that you go to have all of the metadata about your data systems, and hence Metaplane.
nice, amazing. Amazing backstory there. Okay, let's take a few more questions from the audience. I'm liking the type of questions which are coming up.
Fire away.
Yeah, Moavik Investor is asking, coming from a finance background, is MLOps applied in finance field? Interesting.
Oh yeah, the many of our customers are actually in the finance world, whether
Wow.
it's like fintech or investment banks. And this is not so much a surprise because you know, data is a few years behind software, but it's unevenly adopted throughout the world. Where
Hmm.
we find that some verticals like e-commerce and finance uh, and healthcare are the first to adopt very mature data practices, including data observability practices and machine learning ops practices. And the reason is because the data is tied to the bottom line, right? When the data goes down, the whole company is impacted. It's not just analytics or
Right.
reporting, which is important, but it actually is tied to the lifeblood of the company. So I've actually seen MLOps applied a lot in financial fields, right? Whether it's for fraud detection or trying to allocate trades, trying to clean up and classify internal and external alternative data sources, for decision support for traders. I've seen it all over the place.
Right. Okay, that's fantastic. Great. So finance field does have a lot of MLOps. So thanks for that question. Also, a follow-up
Yeah,
question
thank you.
around MLOps itself. Let's take this one. How are MLOps changing the face of machine learning today? Hmm.
I think so. I don't work directly in the MLOps field, in the adjacent data ops field, but
Hmm.
I, if we go back to the history of how data has been adopted in the past decade, right? Not too far back, but remember in like the 2014s and 2015s, everyone was talking about Hadoop and data science, right? Data science is the new sexiest job in the world. Well, I think many companies quickly realize that they are not Facebook and
Hmm.
they do not have a team of 100 data infrastructure engineers to help data scientists, that you can't just bring in a data scientist and say, okay, go ham, if you don't have the right data in place, if you don't have all the support and infrastructure you need. So I think
Hmm.
the introduction of data ops and machine learning ops is part of this larger trend of acknowledging that data and machine learning as one of the killer use cases of data needs a very strong foundation of tooling, of people, and of practices to make it, to bring it not only to production, but also to make it like sustainable and not error prone.
Very true. Okay. We have like tons of questions coming in. Let's take this one. A very interesting question from Mike. Is AI helping transform data monitoring dynamically? Are you implementing ML models at Metaplane to help clients?
Yeah, that's kind of our secret sauce is
Hmm.
we tell our customers when their data looks wrong. But there's many, you know, there's trends in data and there's a lot of seasonality in data. So for example, many of our e-commerce customers, over the holidays had a big spike in orders and a big spike in many metrics. This is not wrong, right? This is just seasonality. And this occurs across different industries, across different types of companies. So that's why machine learning is almost necessary, because you need dynamic and like learned thresholds to minimize the amount of false positives that we send to our customers, and to take a lot of this other information into account. Because going back to what we were saying before, the only reason we exist is to save data teams time. And if we send
Hmm.
too many false alerts, we're not saving you time. In fact, we're costing you time. So, AI is necessary for us and what we spend a lot of time thinking about.
Yeah, exactly. And that also brings me to a very interesting question that I had was, when working with legacy databases, how do you ensure data quality is maintained?
It's a little bit more difficult with legacy databases because, and this is one of the reasons why data observability exists today and not 10 years ago, is because when you have, I'm assuming, shared compute resources, right? You
Hmm.
have like, uh, one user or a few users that are, competing for query space, essentially, is that you can't run integrity checks or quality checks without impacting the performance of actual analytics workloads. So there's a trade-off there. In Snowflake and BigQuery, it's different, right? Because you can infinitely scale your compute. So you can have a tool like Metaplane doing data quality checks alongside you. But as we said before, data observability is not the only solution to data quality. There's plenty of other practices to bring on. For example, defining upfront contracts with the producers of data, like product or engineering teams, so that they don't make changes that'll impact downstream data quality. Introducing some practices like even having CI/CD version control on your data
Hmm.
transformation code, like DBT provides out of the box. This already helps a lot with data quality.
Okay, that's fantastic. Very insightful information. Let's before I take the next question, let's actually get our special guest as well today, since he was talking a lot around Web3 observability. So let's hear a little from Joey. Hey,
The
Joey,
legend. Hey, Joe.
Hey, what's up, guys? How are you doing?
all good.
Good.
I will take this question when you are here, so I can get like two types of insights, because it's one of the hot things today, and that's like, what's your approach for data centric AI?
Hey, Kevin, you want to take this one?
I I'll give it a shot.
Okay.
I think so data centric AI. I think there's many definitions floating around. I think part of it is a reaction to a very model centric approach that industry has inherited from academia, right? From academics, much of your incentive is to publish a paper. How do you publish a paper? You beat the last paper that was rolled out. How do you do that? You build a slightly better model using some industry standard uh, data sets like ImageNet or CFAR10. And I think when applying machine learning in practice, it's often not the most complex model that wins. Oftentimes you can, a linear regression will do just fine for many,
Mhm.
many use cases. The limiting factor is actually the quality and the amount of data that you have. So I think one approach is really to focus on all of the data collection and cleaning and profiling processes first, and then don't even touch a machine learning model, right? Just do it by hand, right? Like look at the data itself and see what you can find, and then start layering on like a simple and progressively more complex model. At least that's how we do things at Metaplane, right? We don't like use the fanciest hammer off of the bat. But curious what you think, Joe.
Yeah, I mean, I take the data-centric approach to everything. Like, I think data-centric BI is also an approach.
That's true.
You know, because I think you hit on something really profound and simple, which is keep it simple, right? So analyze your data, get to know your data, and then apply really simple models and work your way up the food chain. I think all too often we see people, you know, apply a deep learning model out of the gate because that's what you're supposed to do, I guess. And I think for some types of data like image, audio, whatever, like go for it. NLP, like Hugging Face, probably works really well. That's a standard, so go use that. But I think for a lot of structured data problems, like the first thing is to understand your data, which is underrated, surprisingly, right now. So yeah, I'd say data-centric everything, really. So BI, AI, and everything. So
Nice, fantastic approach. Nice one, Kevin. Thanks for that explanation.
Yeah.
Amazing, Joe. Also, Joe, we have a question in the audience from Kate, and she wants to know more about your book, Fundamentals of Data Engineering.
Oh yeah, it's Fundamentals of Data Engineering, written by me and my co-author Matt Housley. So this is coming out, I think summer 2022. Where I'm actually just finishing the draft right now. So, but I figured I'd make a cameo appearance on the Ravit Show and hang out with the good friends here. So yeah, but it's gonna be great. So whenever it comes out, I'm sure I'll be plugging that hard. So. And Kate, congrats, by the way, on your book coming out too. Kate is now an O'Reilly author. So
Yes, colorwise.
yeah, it's awesome. So
Can't wait. Kevin, are you planning to write a book anytime soon on data observability or something?
Writing a book sounds scary, to be honest. How is it? Don't do it.
I don't think you should do it. It's like asking, like, should I take up smoking cigarettes or something? And I'm like, I mean, do what you want to do, but I don't think it's a good habit. So it's.
But the people who did it look so cool doing it.
Yeah,
that's the problem.
It looks cool on the outside. It's hard. It's just a lot of work. I would say that if you really want to get to know your field, like write a book, right? Like this is one of those things where I thought I knew data engineering going into it. And I was like, I don't know a damn thing actually. Like this is hard. So it's a lot of work.
How's the writing process been? Like, you crank out a little bit and every day.
I would say it's definitely a lot of research, a lot of reading, and then writing after that. But especially for a book like this, it's just so broad. There's just so much to cover. So you find yourself going into like nooks and crannies, or like just the recesses of like data, you know, reading stuff from the 90s even, and realizing like there's not. What I realized is there's not a lot of new stuff actually. You're just new things, like things are just being reapplied in new ways. But if you look at the core concepts, like there's not a lot out there that's like brand new. So,
yeah. How do you kind of along that line, like how do you decide what's like evergreen and like worth putting into a book and not like, you know, in the moment fad?
That's a good question. I think you got to look at it from the perspective of, so the approach I took with this was like, okay, so you could write a book about tools, and that's really easy to do actually, right? But then what's the underlying things that don't go away in like 5-10 years? That's probably life cycle, right? So like, how does ingestion work? How does storage work? How does observability work at a fundamental level? And I think these are the things, once you understand that context, I think it's really easy to evaluate tools, or easier, and know what's a fad and what's not a fad. And right now, I mean, there's a ton of fads in the data spaces, we all know, but if you get down to kind of the root nuggets of things, it makes it a lot easier. So yeah, curious about that.
And like you mentioned that you're going back to like the 90s and the 2000s. Is part of the assumption that like if it survived 10 years or 20 years, that's more likely to survive another 10 or 20?
Yeah. I think it's called the Lindy effect, right? So the longer it's been around, the longer it's probably going to be around. And so that's stuff. There's a lot of truth to that for sure. So yeah.
Amazing. Also, Joe, before we say goodbye to you, obviously we want to learn more about what are your thoughts on data observability and this space. How is it evolving?
I think it's really interesting, and I'm glad it's happening. I mean, because for the longest time, observability was like your CEO comes to you, or you're in a meeting with like your CEO or your C-suite, and then they're like, these numbers look really wrong.
Yeah.
Right. So all of a sudden you've like lost credibility for the day, probably for a long time. People lose trust in the data, and like that was observability. but now it's really cool seeing basically the practices of DevOps being applied to data and ML, and I think that's awesome. So excited to see where it goes. I feel like it's super early days in this, and I'm sure Kevin would agree. It's like, I feel like we're all just getting started in this, and who knows what it looks like in 5 years, but I'm sure it's pretty awesome. So yeah.
Yeah. Can't wait, definitely. But it was nice having you here, Joe. Can't wait to have a session with you once your book is out on the Ravit Show. So we'll have that soon.
Yeah, sounds good.
Awesome. Thanks.
It's so great to see you. Catch you around. Nice plants, by the way.
Yeah, thanks, man.
Looking lush.
For sure. Yeah. It's good to see you, Kevin. We'll have to catch up sometime soon. So same with you, Ravit. So yeah.
Awesome. Cool. Thanks.
All right. See you guys.
See you.
What a guy. Okay. Joe's awesome.
Joe is fantastic. The insights that he shares, the Monday morning chats that Joe has, one needs to watch them. So much of insights in so much around data engineering. Okay, moving back. Obviously, I know for a fact we want to learn more about Metaplane. So can you tell us more about Metaplane, about the plans that, the next steps, what's happening there? I would also want to learn more if there are any resources people can refer to at Metaplane. So
yeah, I mean, you don't have to take my word for anything that I say. You can go to metaplane.dev and read our docs, check out our demo, use the tool, and like it's my belief that tools should speak for themselves. And if it's not good, please let me know. If it's good, also please let me know. We like compliments. But what we do is we plug into the most popular data warehouses: Snowflake, BigQuery, Redshift, dbt, the most popular BI tools. We get the lineage from every system to another system, and we have like automated anomaly detection. To go back to your previous question, machine learning to alert you when there's an anomaly. And the hope is we want to make it so easy for every team out there to have data observability. Every other tool in the modern data stack, whether it's Snowflake or Looker or dbt, you can just try it out. Try it on for size, see if it fits you. We think that should be the case for data observability tool as well. Like, I'm an engineer at heart. I don't like talking to salespeople. I actually never talk with salespeople. So I don't blame you if you don't want to, right? You can just try out the tool. And at the end of the day, we hope that, in the future, when there's thousands or tens of thousands of companies who are adopting modern data practices, that they can have an observability tool that they spun up in just an afternoon.
Very cool. And great place to visit, metaplane.dev. I've mentioned the links for folks to actually check out the resources. Thanks for that, Kevin. Also, quick question, which is super interesting. And since you are an engineer, let's take this one. With the explosion of data happening, do you think there are going to be new methods developed for data engineering and observability in the future?
I think it's almost inevitable. I think if we, Mike, I would love to chat with you about this sometime and meet, but I always ask the question of like, what does data look like in 2042, 20 years from now? And this might be heretical to say, but I'm not convinced that any tool that exists today will necessarily be around in 2042 besides SQL. SQL will be here forever. But, even something as dominant as Snowflake, right? Tables distributed throughout S3 and organized in a way that's easy to, that supports analytic queries. How sure are we that is the method for working with this data, right? I think it's possible to imagine a future where everything is streaming, or at least close to streaming, in more of like a, segment type model. And it's also possible to imagine a future where like we're interacting not necessarily with tables and databases, but higher level business concepts via a semantic layer. Because like, let's reverse engineer, right? Like, at the end of the day, it's the use case of data that matters, right? It's being able to give qualified leads to your sales team, being able to produce these features for a machine learning model. and presenting the right analytics to your executives. The current the current methods that we've developed for data engineering and observability is just focused for this specific piece in time, like where we are on the curve of Moore's law. But the moment we get a few years down the line, I can see that changing completely.
Amazing.
I don't know how. I hope as people working on Metaplane, that it changes in a direction that we have more visibility and more control and trust in data, but we'll see.
Yeah, future will tell us how we move, but things will evolve over time. It has always been that way. So makes sense, Kevin. Also, quickly wanted to touch side in terms of, if I come from a client side, or if I look at Metaplane as a place where I want to have Metaplane on board in terms of observing the data and looking after my data. What benefits do companies see from bringing on Metaplane?
Time and trust, right? The same way that you evaluate data observability tools, you are the benefits that you ideally see from it. And the time kind of boils down into 3 buckets. It's reducing the time to identify issues, right? So instead of, as Joe mentioned, your executive telling you that there's an issue 5 days later, you find out that there's an issue 5 minutes later. It's a time to resolve an issue once you found out about it. And these two are related because, unlike in the software world where you can spin up and down infrastructure, treat them like cattle, that the longer there's a data issue, the worse it gets, right? You collect, you miss out on more and more data, more and more transformations are wrong. So the time to identify and the time to resolve are correlated. And also, when you gain more awareness of your data stack, ideally, and this is what we see with our customers, the number and severity of issues also begins to decrease. So those are the time savings. And the trust comes from a heightened level of awareness that many of our users, when they bring on Metaplane or probably any data observability tool for the first time, they're like an aha moment of like, oh, like this is what it's like to know how my schema changes over time, or how the rows on my table like change over time. And once you get that, right, then you start building more and more trust.
Very interesting. And that definitely is, very good to know. That's how things change when Metaplane is on board. So fantastic stuff, Kevin. Also, Mike Nash says, great thinking. Future is equal to data less and higher semantic layer. Like it going to be super exciting. Thank you. Amazing, Mike. Great questions that you've asked today.
That's a great question.
Yeah, exactly. Also, quickly, just wanted to let our audience know that we are giving away 1 annual subscription of 365 Data Science. Today, just need to do is hashtag 365 Data Science. We already have 3 entries, and towards the end of the show, which is just a few minutes away, we will be announcing the winner. So feel free to type in hashtag 365 Data Science. But since we are talking a lot around data, Kevin, I have a very business centric type of question for you, that is also you can say around data, which is, how do you manage data quality in large scale IT migration? For example, migrating like data from SAP HR to Employee Central success factors. How does that work? Would love to know a little about that.
We don't help too much with these larger scale migrations. I haven't seen it too much in the past, while working on Metaplane. I've seen it before then. And the answer is that you manage it very carefully. That you take a lot of effort to, what's the old idiom? Like, how do you eat an elephant? Not that you want to eat an elephant, but you eat an elephant bite by bite. That you want to handle a migration like piece by piece, having your existing system up and trying to isolate as many pieces as possible so that everything is existing on all the use cases are still supported by the old system, and you have like a tiered migration. First of the data and or the processes producing the data, and then finally of the processes that are consuming the data. but definitely not all at once. I've seen way too many horror stories to be able to recommend that. But this is just,
Nice.
logical.
Yeah. Amazing. All right. Also, one industry type question that I had was, which are the industries that Metaplane is already catering to?
One of the best parts of working on Metaplane is that we talk to such a diverse group of people. And we work with many e-commerce companies like Imperfect Foods and AirUp. I mentioned we work with some investment banks. We work with B2B, B2C SaaS companies, edtech companies. So that is the beauty of data, right? Is that a table is a table, right? All of these companies, despite having very different businesses and products and customers, all store their data in databases, right? They all visualize that data using a BI tool, and they also all use Metaplane in a very similar way.
Okay, that's great. Fantastic insights. Also, Kate mentions, please do not eat elephants. It's her favorite.
Yeah, definitely. Yeah, please, no one, isolate that quote and then get me, lambasted and canceled on Twitter. I love elephants. For the record, it's a conceptual element.
Yeah, just for the saying, we don't mean it. Fantastic. Okay, Kevin, it's time for us to announce the winners. So let's do this raffle very quickly for our audience. 13 entries, fantastic. Let's see who the winner is. All the best. The winner gets one annual subscription of 365 Data Science, and the winner is Sakshi. Congratulations, Sakshi. I'll get to you
Congrats.
with an annual subscription of 365 Data Science. Also, that brings me to an interesting question towards the end. That is, where can people find you, Kevin, if they want to learn about data observability, about data quality, about even data-centric AI now? And I'm sure with time you'll learn, you'll be able to share a lot around ML ops too. So where can they reach out to you if they have questions, if they want to learn more about Metaplane, which is the best place?
Add me on LinkedIn. I'm pretty active on responding to LinkedIn messages, or if you prefer email, my email is kevin@metaplane.dev. And if you want to check out Metaplane, let's go to metaplane.dev and give it a spin. I would love to hear your feedback, but really any of those channels are perfectly good.
Awesome. This was fantastic, Kevin. Thanks a lot for the amazing insights that you've shared. And thank you everyone in the audience for asking such amazing diverse questions, I would say. Not only just limiting to data observability, but also around data-centric AI, around the engineering bit, about connecting these through it. So thank you very much. Very nice to have you on board, Kevin. Can't wait to do a 2.0 version with you very soon.
Yeah, Ravit, it's such a pleasure. And also everyone in the audience, I really appreciate the questions. Seriously, keep them coming. I would love to continue our conversations, and we'll talk soon.